Good day, everyone. My name is David Khatebe from Creative Science Brain. So today I'll be actually assisting you with sequencing series, which is the first chapter in your grade 12 syllabus. So today I'll be starting with arithmetic, which is known as linear. Could you please give me time as I'm about to explain this chapter, which is a very long one. So today I will start by doing the arithmetic, then the geometric. Yes, so the arithmetic will focus on how to get your difference, how to get your sums, then how to get your general equation. So we know that actually the general equation for the arithmetic, which is it's Tn is equals to a plus into n minus 1 close bracket times d. So a represents the first term, which is T1 of the sequence. Then d represents the difference between the terms. So each term, like to find the difference, you can say T2 minus T1, or you could say T3 minus T2. You still get the difference. Difference is a result of subtraction. So n represents the number of terms in a sequence. How many numbers are in the sequence? Yes. Okay. For an example, here is the sequence. Just formulated a sequence. So it's 3, 6, 9, 12, 15, 18. So, okay. Then there's a question that says, find the equation of this sequence. So what we could do, obviously, we should find these two unknowns, which is your a and your d. Then you can find the general equation. So we could say Cn is equals to a plus n minus 1 d. So our a would be equal to 3 because this is T1. We said our a is equals to T1. Then our d will be is equals to, let's say, T2 minus T3 minus T1. So it's gonna be T2 minus T1, which is same as 6 minus into bracket 3. All the time, don't forget to put your brackets when you substitute. So d will be equal to 3. So we have our a, we have our d. So we can now find the equation for this sequence. So this will be 3 plus into n minus 1. Then the difference is 3. Now we could say 3 plus 3 times 3 times n. This would give us 3n. And 3 times negative 1, it's negative 3. So our Tn, therefore, our Tn will be 3n, only because 3 minus 3 is 0. So our equation for this sequence, it's 3n. So if you want to check that you are right, then you could say, if you want to check if the equation it's okay or it's correct, you could substitute T1 here. You say 1 here, then you must get 3. If you put 2 here, you must get 6. If you put 3 here, you must get 9. If you put 12, if you put 4, you must get 12. If you put 5, you must get 15. Yeah. So for an example, let me not make things hard for you, so I'll show you an example. Let's take T3. This is T3, this is T2. So let me put 3, then I should get 9. So 3 times 3 is actually 9. So our equation is correct. So let me try and make things a bit strong now. Now I'm making things a bit difficult and a bit challenging. So now I'm saying 3, 6, 9, 12, 15, 18 up until 159. So the question is calculate the number of terms in the sequence. So now they say calculate the number of terms. So calculating the number of terms, this will equate this to Tn. So this is equals to Tn. Then this is how we will get our number of terms. So our number of terms, we said it's n. So now in this formula, we should now calculate n. We already have our a, we have our d, then we can, and already we have our Tn. Now we can solve n. So our a, we said it's 3, then our d is 3 as well, because we said 6 minus 3, it's 3. So now we could say Tn is equals to a plus n minus 1 d. So this will equate that to 159 is equals to our a is 3 plus n minus 1, then our difference is 3 as well. So 3 plus 3n minus 3 was 159, then 3n will be this will cancel, then you are left with 159, then divide by 3, then what's 159 divided by 3? That must be 53 if I'm not mistaken. Yeah, that's 53. So the number of terms that are in this sequence are 53. You should count 3, 6, 9, 12 up until you reach 159. You will see that the terms that are in this sequence are 53. Yes. So let me try and find some questions so we can do them together. Then now the question comes, says find the value of x. So there is a sequence here. 3 x 9 12 up to certain number, up to the infinity, or up to say a certain number, but up to infinity. Let's just say this is T1, T2, T3, T4. So we have four terms in this, which we can see. So finding x will be quite simple, because we could say there is this, we could say, because we said d is equal to d, so we can say that d is equal to d. So T2 minus T1 is the same as T3 minus T2. So the difference between these terms is equals to the difference between these terms. Simple as ABC. So the difference here, 2 minus x minus 3, is the same as 9 minus x, or same as 12 minus 9. So now we can equate and say x minus 3 is equals to 9 minus x. So this is same as x plus x is equals to 9 plus 3. So this is 2x is equal to 12. Then you divide by 2, then our x is equal to 6. So here is equal to 6. So makes sense. 3, 6, 9, 12. So it's also divisible by 3. So the sequence is, the difference between the sequence is 6. It's 3, I mean. Yeah. So I'm trying to make things easier for you as we are about to go to serious stuff, whereby now you need to find the sum of the terms, or the sum of a certain. Yes. So guys, this is actually still revision. So I'm doing some revision from your grade 11. So now let's just say 3 maps x maps 9 maps y maps. So yeah, there is a sequence now. The question says find the value of x and y. So remember from your quadratic, from grade 11, quadratic, something a maps b maps c, right? You had to get your first difference. The first difference is, let's just say it will be b minus a. I'm just doing a typical example. Then that's your first difference, right? So your first difference, it's your linear, from quadratic to linear, then constant. So your constant will be c b minus into b minus a. So this is minus 2b plus a. So this is your constant. So already we are from a linear now. Now we are in a linear. So from a linear, we're going straight to the constant. So a constant is equal throughout. So we can say x minus 3, then 9 minus x, then is equal to y minus 9. Then this is same as 15 minus y. So now we can equate this. Or we can actually equate this from that. Same applies. So we can say x minus 3 is equals to 9 minus x, right? Then we say y minus 9 is equals to 15 minus y. Then this is same as 2x. When you bring this side, then 9 plus 3, which is 9 plus 3 is 12. Then we divide by 2, our x is equals to 6. Then if we bring this side, it's gonna be 2y is equals to 9 plus 15, which is 24. Yes, sorry for that. That's 24. So divide by 2, then our y will be 12, because 24 divided by 2 is 12. So let's check if our answers are right. We say 6, we say 12. So the reason why here I was saying we are moving from a linear to a constant. Take a look at this. This is a quadratic. This is a quadratic. This is a linear. Then this is a constant. So a constant is equal throughout, right? sorry for my handwriting. So a constant is equal, which something that is constant in physics we say something that is conserved. The total mechanical energy is conserved. So we can say this is equal to that, is equal to that, is equal to that. This is same as what I'm saying. It's equal to, let's just say there is a sequence 2 2 2 2. There is a sequence here. This is a constant 2 2 2 2 2. There is no difference between this is 0. So these are equal. 2 is equal to 2, 2 equal to 2 2 2. So this is the same thing. This is equal to that, and this is equal to that, and this is equal to that. So this is simple as ABC. We're moving from a linear, then we went straight to a constant. Rather than coming from the quadratic, we need to go to the linear, then the constant after. Then we can be able to equate. We cannot equate from this linear because there is a difference between the terms, if you get me quite right. So yeah, I hope I could get some other example, but due to time I need to manage and go straight to sum. So I want us to do some sum. So there is a formula for the sum of the arithmetic. So there is the equations. N, it's Sn is equals to n over 2 into 2a n minus 1 d. So we already know the variables. So this represents the sum of the number of terms. Could be sum of 10 numbers, whatever, sum of number of terms that are in a sequence. It could be S2, it could be S10, whatever, but this is the number of terms. Then also number of terms here. Then this is your A, which is your first term. Then D is the difference between the terms. So I hope I'm not quite confusing you or anything, but now I'm getting straight to this, which is the major part of the sequencing series. This is your revision from grade 11. I hope you understand. I'm not even confusing you at all, or I'm trying to help as well for your revision, since you've been enjoying your grade 11 holidays, which is your December holidays. Yeah, I hope you're quite ready for this, because it's a very nice journey. Your grade 12 is a very, very nice journey. It has a lot of work, but worth it. So now, what is the sum of the terms? So the sum of the terms is T1 plus T2 plus T3 plus T4 plus up until etc, etc, or up to the infinity. So this is how you get your sum. But the equation that is simple for you, for your arithmetic, to find your sum, you could use this one, but this is also applicable. So there is a sequence 3 6 9 12 15 18. Sorry about that, need to add a plus here, need to add a plus. This is 18. Yeah, sorry for my mess. Yeah, so this is the sequence plus up until 159. So let's just let's find the number of terms first, so you can get our sum, because we need to get this n and this d and this a, so we can be able to find this when we use this if we use this formula. So we cannot just use it, because we will have two unknowns by that time. Because take a look at this, 2a into n minus 1 d. So we have this and that, but we don't have this. So I told you how to find the number of terms. So finding the number of terms, will use the last term of the sequence, which is same as Tn. So firstly, we'll start by finding Tn, which is 159. Sorry, that's 159. So this is same as 159 is equals to plus n minus 1, which is d was 3 if I'm not mistaken. So we need to solve for this. Is 3 plus 3n minus 3 is 159. Then this cancels out, then we're left with 3 divided by 3, then our n equals to 53. So now we have our n, so you can be able to use this n in this formula. So we can take this n and say Sn is equals to 53, because the number of terms in the sequence are 53. So you can say divide by 2 into 2a was 3, then 53 minus 1, our difference it's 3. So Sn is our sum of these numbers of the terms are 2. It's 4293. So you can say you can call this S53. You can call it S53, which is 4293. Yeah, this is how you find your number terms. So we can take another example, which is a bit different. There is another example. So we have 5, 10, 15 up until the 20 terms. So now this 20 terms, remember we said what is n? N is the number of terms. So now we are given the number of terms, which is 20 terms. So which is this is equals to n, this, the 20. So now it's simple for us to find the the sum of 20 terms. So we could say S20 is equals to 20 over 2 into 2, our a. Let's find our a. In the side a is 5, then the difference it's 10 minus 5, which is 5. So now this is same as 5 plus our n is 20 minus 1, our difference is 5. So let's punch our calculators. So in my calculator I get 10, 5. So it's 1050. So terms that are here, the sum of the 20 terms of this sequence are forming the sum of them is 1050. So when you add 10 plus 5 plus 15 up until the 20th term, you will find that the sum of those terms add up to 1050. So if you say T1 plus T2 plus T3 plus T3, which is a very, very long way, in your exam you need to manage your time, so it's better if you use this if you use this formula. So let's now find the general equation for this sequence. So now we could say Tn is equals to plus n minus 1 d. So the difference between this is 5, then this is our a is 5 as well. So okay, say Tn is equals to 5 plus n minus 1, then the difference is 5, then this is 5n. So this is 5n. So this is actually 5n. Here is a question that says, the first term of a linear sequence is 18. So this is T1. So collect the data. T1 is equals to 18. Then the fourth term of the same sequence is 48. So this is T4. T4 is 48. And the last term is 1200. So the last term is the last term. Could call this L. The last term is 1200. So the question says, find the difference between the terms. So in simple terms, find D. So the thing that I told you is A is equal to T1. So T1 is equals to A is equals to 18. So remember from grade 11, they said your A is T1. So this is same as A, then A plus D, then A plus 2D, etc. So A plus 3D. So our A here is 18, so T1 is 18. Then we don't have our T2, we don't have our T3, you have our T4. So our T4 will be equals to, T4 is equals to A plus 3D. So we can equate this and say 48 is equals to A plus 3D. So now we have our A, which is 18. So 48 is equals to 18 plus 3D. So can transpose this side, and we find that this is equals to 23. So if I'm not mistaken, that's 48 minus 18, which is 30. My mistake. That's 30, yes. Then divide by 3. So D is equals to 10. So the difference between these the sequence, the terms in the sequence is 10. So from 18 we should add 10 up until the last term, which is 1200. So the next question could be, find the general equation for this sequence. So finding the general equation is simple. We already have our A, we already have our D. So this is Tn is equals to 18 plus n minus 1 D. So the difference is 10. So this is 18 plus 10n minus 10. Then Tn, 10n is equals to 8 plus 8. So Tn plus 8, yeah, 10n plus 8. So this is the general equation for this question here. Now the question comes and say, calculate the number of terms. So now we need to calculate n. So guys, now I tried giving some space so I can solve that problem. It seems like it doesn't appear very well, so I thought of taking the data, which was it was given that T1 was equal to 18, then our T4 was equal to 48, then our last term was equal to 1200. So this was the data that we have been given. Then we solved D, and D was equal to 10, right? We're given that D is equal to 10. Then obviously this is our A, because A is equal to T1. So this is our A, which is 18. Then the question was solve the number of terms in the sequence. So we all know that the number of terms in this is same as Tn. This is equal to Tn because it's the last term. So this is same as T1. T1 is 18, so I will write it as 18 maps. Okay, let me just say plus. Let me make it a sequence for sum so we can add them. Then T2 we don't have, then plus T3 plus T4 is 48, plus up until 1200. So it must appear like this, up to 1200. Yes. So now let's just focus on this thing, because we're if you can, the difference is 10 here. So if you keep on adding 10, it could be 28, then you add 10, 38, then you add 10, 48, because the difference is 10. We solved it on the previous question. So now we're calculating the number of terms. The number of terms in a sequence, we equate this to Tn, which is the nth term. So now let's say you calculate the number of terms. Calculating the number of terms will be obviously the general equation, which is Tn is equals to A as n minus 1 times the difference. So there is our difference. So Tn we have 1200, then our A is equals to 18 plus our n, it's something that you're looking for, then our difference is 10. So 18, this is gonna be 18 plus 10n minus 10, 1200. So if we will be left with 10n plus 8 equals to 1200. So if you bring this side, it's gonna be 192 is equal to 10n. If you divide this by 10, then you divide this by 10, no, 10, just 10, then this cancels out, then it's 119.2 if I'm not mistaken by that. So let me check on my calculator. So this is 1192 divided by 10. Yeah, it's 119.2. So you need to round this to the nearest integer, which is 119 terms. So there are 119 terms here. So now we can say the next question would ask, sorry for that, the next question would ask, calculate the sum of the 119 terms. So you will be calculating as 119 will be 119 over 2. So I'm taking this formula, remember this formula, n over 2 into 2a, so n minus 1 times the difference. This is the exact formula that I'm using here. So it's 119 over 2 times a, my a is 18, plus n is 119 straight, minus 1 times the difference, which is 10. So let me quickly use my calculator. So I get S119 is equal to 72,252. So this, guys, is quite simple. You understand that everything, it's straightforward, because calculating the number of terms will lead you to find the sum. If the this let's just say, for an example, you were having this, they gave you this, the sum of the 119 terms. So you were given this, then they said, now calculate the number of terms. It will be simple. You'll be solving for this. You have that, which is 119, which is 72,252. So you'll be solving n now. So this will be your unknown. Then you already have your a, which is 18. Then you have your d, which is a difference. You see, now you're going back, because this time we were solving the sum. But if you were given the sum, then they say find the number of terms, then it will be simple for you. You just reverse this working out backwards, then you will find the number of terms. It's quite simple. It's nothing that is problematic here. So I'll try some more questions if you think they are not more, but I think I would create another video focusing on more questions of sequence and series according to referring to arithmetic, I could say, because now I just want to head straight to geometric, because quadratic, it's something that we did on grade 11. So there's nothing that is new. It's still the same thing. When you want your same thing on a quadratic, there's nothing that has changed. So there's nothing more that I could explain, or unless I do revision with you, I'll try to create a video doing revision with you in quadratic patterns, I would say. Yeah. So the next video will be about geometric. So this sequence, it's new from you guys, but it's geometric sequence. It's very nice and understandable.